you. That was a great introduction. I hope it did not disappoint because that was my teaser from the other room. So I'm going to talk about my experiences. I work at. I'll go into this, but I'm going to talk about my experiences in practice and what are kind of ongoing frustrations for me. And what I see as kind of new challenges in what software engineering, and I know this is kind of focused on architecture, so in addition to general software engineering, I want to talk about some architecture issues as well. I have built some pretty big ML applications at Google, and I see some practice, there's how it's evolving to meet these challenges, and I want to talk about those things. Then I'll shift gears a little bit and talk about cloud a little bit. And this is one that I have some frustrations with, but the widespread use of cloud and how it constrains designs and the benefits and weaknesses of these constraints. I want to delve into that a little bit with folks. I kind of believe quite strongly that software engineering, because I am a software engineer, I came out of the program with George, has a key role to play as practice evolves. I don't think either one of these things changes the game enough to throw out everything we've learned. All right, let's see if this works. Okay, so going back to my background a little bit, which I think helps you, because sometimes I've found people, you say, I work at Google, and they think you were there in the garage with Sergey and stuff, and that is not what has happened at all. So these are kind of big blurbs. So George mentioned I was in the Air Force for 20 years. I graduated from the Air Force Academy in 1987, and mostly my entire career I developed military software systems. I was the last of a dying generation of officers that actually did technical work. That was incredibly rare even when I was in. I never worked for a wing commander that wasn't happy to have a captain, major, lieutenant colonel that knew something about software, and they always wondered why there weren't any more. But I think that that has kind of died out. But I worked on various systems, including NATO AWACS over in Europe. I did work at their wargaming center. In fact, I'll make a shameless promotion. If you Google Halloran and StratWar, I wrote up a very long practicum of a military simulation war game that I did in the late 80s, and it's still kind of surprising me how much that applies today. But that's another whole talk. Then while I was in the military, I was finishing up work on NATO AWACS, and I wanted to find out what to do next. And I actually called up some friends of mine on the faculty at AFIT and said, I'm a little senior, but do you guys need instructors? And they said, sure, find a PhD program, go do it. So I ended up going to CMU, and as George said, after 3 years taught at AFIT, but I worked for Bill Shirless, and I got very interested in program verification and formal methods and the practical application of that. And that was with Bill Shirless, and we started a startup called SureLogic, which you can Google as well. It did not make me millions. After 8 years, we kind of shut the doors. I think that's another whole talk, which we're not going to do today. But kind of building practical assurance tools for Java was what this company was about. We did dynamic and static analysis. So I have a lot of background in that and a lot of interest. After that, I went to Google. And I don't recommend this technique, but I went over to Bakery Square and talked to the site director and said, I'm the worst match for what you do that you have ever seen as an engineer. So I don't really think there's much interest in you hiring me, but it's kind of opposite day. They were like, oh no, come. So I went over to Google, and I've been working there, and that's largely a lot of the content is coming from my time there. So hopefully that gives you a little bit of background. So at Google, what am I doing? I'm what they call a TLM. So I'm a tech lead manager in the systems. I do some technical work, but this is about what I do. So first thing, I have two teams. One does the product reviews for Google Shopping, and the other does human labeling for ML systems. What I usually do is check in with them. I triage the fires. This happens more than you would think. There's operational things going on all the time. I spend a lot of time in people, team, and project meetings. That's probably the biggest bulk of my time. And then, like, most of you probably can't read this, but it says work on code because that's so small that it doesn't get going, and I'd love that to be more. And then also a little bit on personal growth. I do some kind of outside things. Like for a long time, I think I had the only copy of the Bazel build tool that Google released open source working on a Raspberry Pi, and I used to contribute patches to that so it would still work, because I was a big fan of that. So that's kind of what I do day to day. How did I end up talking about ML and cloud? So learning from data, or my ML life here, I really had very little background in this when I started at Google. So I showed up and I was there for like 2 days, and they said we have this big ML system. It does classification of ads into a 6,000 node taxonomy. Lead this, go. So that was where I started. And of course, I was thinking that it would be like I would get to do cool like logistic regression and all this other stuff. No, never touched any of that. So I want to talk a little bit about my experience with kind of the hype versus reality of these. And to kind of spoil this a little bit, there's a little nugget of this stuff, the learning algorithms and the models, but there are huge surrounding systems that are what creates the quality stuff. And this is quality enough to drive like websites and things like that. I was really excited to hear Phil's talk earlier. He's in a whole different world when you're, safety critical, mission critical. I don't have to have quite that thing, but there's huge surrounding systems that I think need like what architects and software engineers provide. So we need, and I'm going to talk about this some more later in the talk, but we need architecture, patterns, analysis, and design skills. What I wish I had, so if anyone here is going into this kind of world, I wish I had a whole lot more statistics when I started. This was not my great strength in mathematics when I came in, but it really does help to understand that you're really kind of getting a statistical prediction and generalization of these ML models, which we're going to talk about, is important. Okay, so the first thing I want to bring up is I've noticed there tends to be a sense of, maybe others I'll kind of survey, is that ML like replaces traditional software engineering. And I think Phil Koopman kind of spoiled this for me. But has anyone gotten the sense that like you're working on a problem and the immediate answer is we should use ML? Is there anyone else who's show of hands? Anybody else? Okay, so I think this is, I've come to the conclusion that we should view ML as it is a tool in the toolkit, but it certainly does not solve all problems. As Phil talked about, the doer checker, which maybe is a pattern of implementation there, doing that checker with an ML system is probably a bad idea. Probably we need a more traditional system. So I think you have to consider carefully the problem being solved. You really think about this deeply. And this is probably a terrible characterization of it, especially if you get into like self-driving cars. I'm more in like, is it good enough for like to put an ad up or something like that? So I'm in that kind of world. So set your things there. So it's a precise answer needed. And by logical, let's just say we're going to code something up, like an algorithm, a heuristic, or something like that. So for example, you wouldn't want your calculator to be an ML model that just didn't learn about how to do division and gives you like random answers because it only knew multiplication and subtraction or something. The other one is your sort algorithm is unlikely to be very, things that you can do this better. I also think like I use compiler is another one. You kind of want your compiler to output object code that will actually work. Maybe you could hedge a little bit. Maybe there's some ML that you could use to decide whether or not to apply certain optimizations or something, but generally you want a precise answer. So logical, statistical, and by the way, the logical and statistical, George thought those up, so thank you, George, the characterization. If a best guess or as good as possible is part of the problem. So for instance, guess the user's next query term on like google.com. That's a great application of an ML system because it's difficult to predict and just guess. So you can learn as you go from logs or something else, and the model will hopefully do a better prediction than a simple algorithm or heuristic will. I also think there's a dimension here that's a little more tough to characterize. Once it gets to a certain scale or complexity, maybe you can apply ML to try and help you wrangle all the variables and things into something that gives you an answer that's maybe useful. But I caution, as you go into this world, carefully consider the penalty if the machine learning gets it wrong. The kind of things, and this could be a penalty like the car smashes into someone, which is what Phil was talking about. But when I wrote this, I wasn't really thinking about that. I was thinking more about, like, if you get it wrong, what are the, like, are there like financial impacts? In my world, that would be kind of what happens. Like, we depend a lot on ads for revenue at Google. So when my teams mess up, they can hurt revenue. You also can have teams, like you can have PR, like where you predict something wrong, and you can search like ML gone wrong and find all kinds of examples of this stuff. It's not hard. But those can be like PR for your company and make the company look bad. So when you apply this, think hard about what's the penalty here if you get it wrong. I'll also bring up the biggest thing I've noticed in the systems I've worked on is realize that ML is never going to be perfect. That's usually the number one complaint I get on the systems is we have this huge classifier. It probably performs at about better than 90%, 95-ish. So guess what the number one requirement people would like it to do? 100%, yes. Very savvy. Well, the problem is if you're in this world, you're unlikely to get there. So you have to be in a problem space where 90%, 80, 95% is acceptable. And just fine. And if it isn't, then you maybe can't solve it, or time to go up here and augment it. All right. Okay, I liked this diagram because it kind of gave me, I was trying to give some sense of like what it felt like to me working on this stuff, and it's kind of hard. The team was pretty large, like 12 people that was doing the team I joined. So what happens is when you're in these systems, the learning algorithm is this little bitty part on top, and it feels like the elites work on that. We had one person that actually did this stuff. I was involved in a very big launch where they changed the way the ML learned. It was a technique called MDL that I won't go into, but it was a different kind of learning algorithm. So that's like the top. Little angels flying around and stuff. But most of the team and everybody else, and I'm like in the middle of this melee of surrounding systems. And what are those things? They are human labeling systems. So this was obviously, by bringing up that, it's a supervised learning system. What that means is we have to create training examples, we feed it into the learner, and then we get a model. So this had a huge human labeling system with people on, in Europe and India and the US, all collaborating. It was probably 300 people that worked on that part, that actually did the human labeling and management. We created all the tools for that. You have to store this stuff. You're getting 1 million plus labels a day. That's a non-trivial storage system. Metrics about this, one little non-obvious thing, maybe some of you have dealt with this, is when you're dealing with human processes like people labeling examples, you have all kinds of things. You want to check that they're doing this and not just hitting the no button all the time, or you can envision like put it on no and put the book on the key and let it run really fast. So all this stuff has really happened. So you have to build like kind of checks and balances, and we have levels of quality assurance that are built into this. A reasonably complicated system. However, that's a system that like traditional software engineering, and there's great architectural patterns for that kind of system. Training and evaluation of models. So clearly, probably most people would think of this, if I have data, I kind of train it. So I have to build a system to train it. But The hard part of this is evaluating those. So you ran some training data through and you got an ML model. Then you do it the next day with a little more training data and you get another ML model. How do they differ, and is one better than the other? These are hard questions. We'll go into this some more. Feature engineering. This is where you kind of go from the geniuses that come up with the learning algorithms, maybe like at Google, they're researchers, to the folks that, this is where kind of the real excitement happens in building a new ML system. You have to figure out what are you going to inject into this thing and how so that it creates an answer, okay? And sometimes this requires a little bit of skill. And the folks who do this are really, really good at it. And I'm not sure we've captured best practice here. And it's also evolving. Not to get too technical into ML, but the linear classifiers that were like pretty prevalent at Google and that I still like largely maintain, this was really required. You had to be very savvy about your features and things. The deep learning neural nets that are starting to take over claim that you don't have to do this as much. However, that remains to be seen. But this is kind of figuring out, if you think of ML as I shove inputs into one side of this and it gives me an answer. And in my case, the answer is, what category is this ad in? But I have to figure out what do I pull out of the ad to make that decision, and that's feature engineering. Secondly, I'm going to go into this in some more depth, but experimental support and measurement. How do you release these things and the huge surrounding systems to safely put this thing out into production? And by safe, I mean don't damage revenue in my case. In Philip's case, it's much more critical. So all of this stuff at the bottom, a big melee of people. I think all of this stuff needs software engineering, and nothing I learned in my past at the Air Force or AFIT or SureLogic, that stuff all applied, and ISR at CMU. It all applied. It all applied. Oh, and I forgot to mention, but I think it probably applies to the top part too. Hopefully these learning algorithms have been checked and they're tested, all the kind of classic things. You certainly wouldn't want to bug in this stuff. That would be very bad. So drilling into this a little bit more, you could probably ask 30 or 40 ML practitioners to draw kind of box and diagrams, and they would draw something different, which is things. But in the systems I worked on, to kind of give you a sense of what's going on, I mentioned the human labeling systems, the label data management. You need some model training infrastructure. There's the model learning algorithms. This is what ML researchers get into, and that's the fastest moving part. So you want to, that's where they're going to be changing things out from under you. You have to serve the model somehow, whatever you're using it for. You need some way to evaluate new models and move them into serving. Online monitoring of the production system. This is a little bit, it was interesting to Phil's talk. Everybody will probably remember doer checker from the thing, but this is probably, in Philip's world, the checker. Is this doing what we expect? You might have some constraints on it, or at least page someone if something's going on. And I'm going to talk more about experiment-gated release systems and why that matters. But if you do it, are there folks who build ML systems other than me? Is this? Yes. So your boxes may look different than mine. And I think this is an interesting thing. If you drew something up, you may have different parts, because I'm dealing with a supervised learning system that's used for ads at Google if you're doing something different. And a lot of systems at Google look a lot different than this too. A lot of them are logs based. We don't have any logs in this case, so that's unusual. What's going on here? And hint Parnas, I was kind of hinting, and as you start to draw these boxes, I think these systems have evolved from where they kind of did them all together to we're starting to see an attempt to break this stuff up into parts we can hide. We can set up boundaries and interfaces and hide the details of. So you can see that you can imagine the labeling system standing alone, hiding the details of how it does quality assurance with the human labelers from the rest of the system. Monitoring systems could monitor models that it doesn't even know how they were trained. You're starting to try and get some information hiding going on here. All right. How am I doing on time, George? 25 minutes. Okay, thanks. All right. So this is I think analysis and design shifts. One of the reasons is, well, hang on, go back a sec. The data management here, I don't know whether I'm conveying this well in my slides, but in a lot of the traditional systems, you're thinking about specifications, architectures, and designs, which we do, but we're thinking also about the data we have. And you can see a lot of the boxes have to do with building up examples to train the learner. So data, control of data and getting data and how you get it and whether you believe, what the properties of it is becomes very important in these kind of systems. So I think that analysis and design doesn't go away in ML. It just kind of shifts a little bit. And these are kind of some bullet points. I think there's definitely an iterative process. I copied the spiral model. I'm pretty sure that's what that is. Wikipedia. So feature selection and data analysis of model use kind of come to the forefront. Evaluating whether this learner, Philip talked about this a lot in the keynote, that what do we really know about this model that we've created? Did it learn that people are somebody who wears, oh, and I took the badge off, so I can't use the prop. The people who take have a red badge are people, and if you don't have a red badge, you're not. It's very hard to tell from these things whether or not that's what the learner did. And it becomes harder as you get into these deep neural nets, that they're very hard to explain what's going on. In the linear ones that I work on, engineers can actually look at what comes out of the feature weights and look at what happened and really can get some decent answers about why something did something strange. But, and maybe make changes to the features. Precisely what to ask humans is a big problem. So what this is getting at is you need training data to train the learner, but if, in my case, you're collecting answers through like a form from people like Mechanical Turk-ish like thing that Amazon does, what do you actually ask them so that you get the training data you need to build a model that actually does what you want it to? That is pretty hard. I think staying at a pretty high level is important here. Sometimes you can be so inundated with details of like the ML models and people like to talk the details. Staying focused on what are we actually trying to do and how are we doing it and is it being effective can do it. So stay on the forest. I also, my personal experience is kind of know the lingo. At least at Google, they talk a lot about precision and recall, which was weird to me because I come out of the program analysis world and we talk false positives, false negatives. So, I mean, low precision means you have a lot of false positives. Low recall means you'd have a lot of false negatives. But this is a Wikipedia diagram that has helped me immensely. So highly recommended. And I've already mentioned this, but you can't target perfect with these systems. So if you're starting off with a thing that 100% of the time we have to be exactly right, it's probably not an ML type system. All right. So software engineering, what's different here? I think this is kind of the getting to the heart of like what is different from if you're building a traditional system like I built NATO, AWACS, command and control. I built the simulation. I was telling people to go look at the practical of strat war. What's different from doing that? All these giant surrounding systems can be developed with best practices. I strongly believe in that. So if people are telling you, oh, it's ML, we don't need to follow architecture and design best practice, I don't believe that. But the use of the model shifts your focus to data a lot. Label collecting and selecting labeling candidates, we haven't talked about that. Labeling candidates are what you actually put in front of a person to ask. This is very important and has consumed a lot of time in the groups that I work in, deciding what the best offers out of literally billions of ads, which one should we put in front of humans, because it's only a very small subset of that we'll be able to ask questions about. Selecting those is important. Feature selection and design, mentioned that, and deep learning. So your focus shifts a little bit to trying to figure out what the inputs and outputs are, and this becomes the more ML-ish part. Now Now, I'm going to go into these on the next slide, but once you have training data, you have training, and you have a model, now we're getting into how do we use this thing and get it into production, and what kind of surrounding systems do we need to do that. So I've repeated the bottom part of that. So in ML literature, model evaluation is pretty principled, but beware of bias. So what they do is they compute these precision and recalls, and typically how this is done is you have a set of training data, right? You take some subset of it, maybe 20%, and there's various techniques for doing this. You train on the 80%, then you run an evaluation on your 20%, and that's how you compute precision and recall. So that's pretty principled, but many things can go wrong here. There's a lot of assumptions about your training data there that might not be true. It usually assumes they're sort of randomly sampled out of the population of data that you do, and that means you can trust precision and recall if that's true. In my experience, it's never completely true. So I view this with a bit of skepticism, but you'll find a lot of ML, I mean, it's useful, but I wouldn't trust it 100% is what I would say. Very useful. Certainly if you have a higher precision and a higher recall, it's probably a better model. But if you have bad evaluation data, that could be skewing it. So the model, that's kind of the first step. Second step, evaluation of generalization. Now, we haven't talked a lot about this, but what our hope is that this ML model generalizes. So I get to train this on maybe a couple million ads that I labeled, and it's going to be applied to billions. So my serious hope is that this thing generalizes to that billions and works. That's the goal of the system. And in my case, whatever problem you're solving, that would probably be your goal too. This gets way more ad hoc, but I think it's just as important. So for example, if we're trying to put out a new version of this, one of the things we're looking at is how much did it change from the last one. So if we classify with the old model, and we've made some changes and built another one, we classify the entire corpus with the new model, we can look at like percentage of where classifications changed. And we use the term churn, like how much did classification churn. This is a evaluation of the generalization. And it's also a bit of a risk evaluation. So if the churn is like 1%, and this thing's only getting it like 90% right to begin with, most of you would probably argue that there's pretty low risk in putting this new model out, provided its original model evaluation was a bit better than the old one. Anybody too concerned about that? Nope, I'm not either, I'd be good. However, if the model had much better precision and recall and the churn was like 75%, you might get more worried. So that's an extreme example, but you might get more worried. So this is kind of getting into techniques of evaluating whether it generalizes well. Now the problem we have is we don't actually have ground truth for that 75% that changed. So we don't know if it's better or worse. So you can do evals where you actually look at things side by side and things like that, but it's a tough area. But I think this is just as important as the model evaluation in a real world system if there's some impact of this being worse. And in my case, it'd be revenue would get worse. Then let's talk about how do you mitigate that. So even after these two steps, we can be concerned that generalization of this model is not as good as we would like it to. So how do we mitigate that factor? So if our risk, as in my case, is revenue, what we can do is we can do an experiment-gated release of this thing. So you've probably heard of like canarying software on the web. So this is exactly that, however, with a slightly different goal in mind. We're not really checking if the software is just going to die. What we're checking is whether or not we have some level of metrics and they aren't just tanking as we roll this out. We can look at the part we're running with the new model, and we can make sure that the metrics are not going down. So this drives you to where these metrics you're doing and how much you trust them are important. So like if you're doing this kind of a system and rolling it out, being fairly confident if you can do this, that your experiment-gated release, you actually believe these metrics that it's telling you, and you make decisions on them, I think is important. So this is really what you're worried about. So it might be loss of revenue, it might be user engagement, it could be, you know, the car doing something bad in Philips things. This is quite a bit different than most of the time we think about in traditional systems, the regression test suite. So this might be unit tests to integration tests to kind of system tests. And then when that's good, like when I was at SureLogic, that was how we did it. So we had 3 or 4 tools. We went through all the systems, had a new release, gated them up. And then the very last thing I would have the engineers do, which this you'll probably find pretty funny, we had all our engineers sit down and I made them go through all of the tutorials and the documentation on every single platform in all of the tools. And you would not believe how much that caught things, either in documentation or things. But regression test suite. Then, of course, we take the bits and we put them out and release it to the customers. So that's a little bit. So the regression test suite, we have experiment-gated release versus regression test suite. So pulling up a little bit of our literature, Fred Brooks, The Mythical Man Month. I hope everyone here has seen this book. Is there anyone, this is a new thing? Well, this is my signed copy. Fred signed it for me many years ago. But he said on page 20 that he kind of viewed timing of scheduling of this stuff as basically a third planning, a sixth coding. And then the interesting part at the time, which was controversial, was half of the time in the software project was testing and release. So he was planning half of the time, which was at 1975, that was pretty controversial. I think this is, I'm kind of mapping his chart to what I view the world as ML. So we do this, you know, planning and coding is roughly the same, just building models and things, but model tuning and eval and generalization and release can easily consume half the project. So I have seen projects where I am where we spent like 6 months doing getting the system to the point we needed, it could create models, but then the model evaluation, tuning, generalization, experimental release can easily take well over a year. And in fact, like one of the releases I did, which was the MDL one, definitely was in that kind of category. I've heard of much longer time frames where they can have working systems and it can take 2 years to get them live. So this can consume a lot of time. So the point of this was to highlight, thank you, Fred Brooks, for his excellent work on the Mythical Man Month, highly recommended. But I think that like this may be a little bit surprising today because I do think we're a little better at this maybe than we were in 1975, but definitely with ML systems we have a similar parallel. All right, what's missing? I think we lack architectural patterns for these ML systems. And why do we need different ones? That's probably not that's probably a good question. The data focus and generalization problems to me seem like they're a differentiator. Versus like enterprise systems or more like standard systems that we've been building for a long, long time. Today we have things codified. So TensorFlow Extended, which covers some of these outside boxes that I drew in my earlier talk. Just raw TensorFlow is kind of like the simplest, build something in Python and get a model. TensorFlow Extended, which has been open sourced, has some of these boxes. So it's codified there. Microsoft has visual tools for AI. Also another attempt at some of the surrounding pieces parts. And there's a whole gaggle of startups. I mean, there's lots of ML startups going on here. So this stuff's codified there, but I don't know if this is good or if it's just what we have to live with because that's what's out there and it's way easier than, you know, if you don't have a team like I do to build all this from scratch, it can be there. So my challenge with this is, and I don't have a lot of great answers here, is can these be documented? Like, I definitely think Phil's like doer checker, that's like an example. It's definitely a way to like start to think about safety critical systems with ML inside them. But trying to get architectural patterns for these systems, I think, is a challenge, hopefully raised to everybody here to be thinking about. I mean, I have some ideas, but I think it's a tough area and it's very diverse. There's lots of differences in things. And listening to Phil's talk earlier versus what I deal with every day, the diversity is even more, comes home to me. Okay, short aside, we're going to start to shift over to cloud. And I don't like to do talks without a little bit of code. There is a point to this, I'm going to come back to it, but I figured we'd take a short break and I would ask for audience participation. Most of Google Shopping uses C++. Now I have, like, my previous startup was Java, Java, Java. Josh Block was on my thesis committee. He wrote effective Java and most of the Java standard library. So I went into C++ and I've been, well, less than thrilled at times, but it's better than it was years ago. So this is an interesting one. How does this work? What the return type of this function is void. Is this legal or not? What's going on in that? And I have really seen this in code. Any thoughts? Is that, but let's go. Is it legal? Nobody? Is it illegal? Okay, nobody knows. Somebody said illegal. It is in fact perfect. Yeah, well, I am, sadly. But it is absolutely legal in C++. Bar, it has to return void. So it's returning void and it can return void. I have literally done CLs at Google to fix this kind of stuff. To me, it's utterly confusing. Does anyone know what this is doing? I'll tell you it's a standard map. What is this check doing? Yeah, you're puzzled. I would be too. That is saying, is the map empty or not? Perfectly obvious from this, right? Ooh, this one's a subtle one. So we have a standard string, which I didn't put standard, but that's what it is. And there's a standard string view, which is like a reference to it. Is this okay? Will I end up with, if useDef is true, I should end up with def. Otherwise, I should end up with ABC. Well, you don't. What happens is this, unfortunately, casts the objects up to the, this is a string literal, that's actually a string object. It moves them up, and what you end up with is if you end up with this one here, you will, with def. If you end up with def, it will construct the string object here to return it. You'll get a reference to that, and then it will immediately free the memory, and you're pointing to like bad memory. So who knows what you'll get. In my examples, you ended up pointing to somewhere in the stack with some things. I love broken programs and what they do. So this is an anti-pattern. This little gem, which is quite concise, is trying to declare a constant. Why should that be hard? It is, sadly. This is another fun one. Your C people should be able to tell that. Hard to see, but the key bit, which is maybe give a little bit of hint, is this little indicator. So does anybody know what bool star is? It's a what? Pointer to the Boolean. So this check here is not actually checking if you're done. It's checking whether or not the pointer to the Boolean is null or whether it references something. Boom, that's probably not what they intended. And then anything involving this, which for like this is casting to an R value. It's very confusing. The fact that that has to be in the language is sad. I understand why, but it's sad in my mind. So frustration. So shifting a bit to cloud systems, and like I said, I'm going to come back to what we just talked about there in this talk. But this is one where coming into Google had a lot of exposure with kind of the big systems they have. So this is definitely like personal. This is not like an indication of the whole cloud universe. Some of you may have different opinions, but we can talk about those. First one, I think, is programming languages. We kind of have the model of kind of one process in threads and then code running in these things. I think this is getting a bit stale for like terabyte size processing and serving on like multiple systems. I regularly fire off test cases that use like thousands of machines all the time. And we use this Flume thing for a lot of these. But it just drives me crazy that the cloud support, we have all kinds of failures. We do have a little bit of constraints, the map reduces and things. and processing threads, but trying to get like better mapping between kind of this cloud environment we did and what the programming language is able to express easily is great. So a lot of the languages we're using, like I'm writing this in C++ a lot of the times, they have decades of baggage and they're pretty married to this. So I'm hopeful that like there will be some emergence of like new thinking. And I think there is with Spark and Flume. It's still not quite where I'd like it to be. And I'll talk about why. Kubernetes, which is kind of like the thing we use, failures are a problem. In fact, I'm going to jump down to this one and then we'll come back to the others. But reliability. When you run ls on your Linux box, it finishes and gives you a listing of the directory, right? Too often it feels like I fire off one of these pipelines and I might as well just flip a coin or roll a dice as to whether or not I'm going to get anything back for it. It's too much of a dice throw. Much better reliability for things would be nice. Which leads me, I'm going to go up. Quotas. System guys seem to love quotas. You have so many quotas when you put in a cloud system. You can map everything, spindles on disk, you can check how much network you're using, you can check how much local things you are. But honestly, there's just too little programmer time to deal with this stuff, so we have to simplify this stuff. I hope there will be a trend towards simplification. But this has gotten to the point that like you need experts in this just to keep going because the programmers can't figure it out. And what they end up with is, here's a job I need to get done, and it just stops halfway through, and we don't know why. Ran out of some quota, boom, you're done. This one drives me a little bit crazy. A lot of the solutions we have kind of assume read-write file systems, and a lot of them are like write once, read many kind of systems. And like I have many times been frustrated where why can't I just use something like a file system, like a full file system? This is a little too, for me, a little bit too much of a constraint. I'd like to see this done, especially, and I will say especially for small data things. Maybe if you're in the terabyte range, you can write once, read many times, but if you're in the like megabyte range, why can't we just do direct access like we always did? A huge one down here. A lot of these systems move you away where you don't have a debugger, or at least that's my personal experience. So you end up having to do logging, which is really driving the need for Dremel kind of tools. Where this is kind of a system, again, open source, but a lot of us use this to query logs and things like that inside Google. It's just like an SQL thing that can query logs. But you know, dropping off to logging when we've like spent decades developing good debugging techniques seems like a huge step backwards, and I'm hoping that that will be another area that cloud will kind of focus on. How am I doing on time, George?
About 45 minutes.
Oh, super. We're doing good. Okay. Design, this is like my experience too. Some of you may have different ones, but cloud constrains design, at least in my experience. And the design space is constrained by kind of the tools you have to do this, which I expressed some frustrations about on the previous slide, but also by the infrastructure you have. So there's pros and cons of this. Pros is you can have lots of successes. In fact, it stunned me when I arrived at Google that people could write these like 4 or 5 page design docs, march off, build systems, and have success like time and time again. And what I came to realize over time was these constraints they're doing, which is like if we think of the whole design space as maybe a Venn diagram, I'm going to get a little sloppy with notation here, but in the cloud thing, we're really focused in on a very narrow space of the design space, and that actually, by that giving those constraints, that actually helps repeatable success, I think. So that's good. The bad is outside the chart. If you got to go into this, like you got to go out of here into this area, you're in really shaky territory. It's risky and it's uncomfortable. And it's not only uncomfortable to you, maybe you know how to do it, but realize everyone who's looking at your designs and things is super comfortable and had lots of success in this. So if you're proposing something out here, no matter how worthy it might be, it's going to be viewed with a lot of skepticism. So you kind of end up with these pieces parts like A, B, C. This might be your database system, how you do your pipeline or something. And if I put up a new design, you know, I say I'm going to do A, C, and D, but maybe not B. I'm going to check off the stuff I'm going to use, and maybe I don't need that one. And then, of course, you get the deep design review. Well, why not B2? That's there. So use the stuff that's there. So I think this is there's the pros here are you can have a lot of success because you're constraining people's design. I mean, a lot of this stuff is like if you're really up to scale, map reduce. You're using write once file systems. You've got a lot of constraints on the design, but people can have success. I worry that we're, losing by not having the other options available. But folks may have other opinions. We can chat when we get to questions times. So cloud in practice. Unlike ML, which my takeaway was, hopefully we can add that as another solution in our toolkit of solutions as kind of designers. There are some problems that really fit ML, others don't fit ML. This one, I think there's no question cloud is here to stay. I don't think it's going anywhere. It's been long predicted, and I'll give another plug. Mitchell Waldrop, the Dream Machine, talks about Licklighter, and he this is way back 60s, computing utilities and kind of his intergalactic computer network, but he was really predicting, I think, like a vision of kind of what's become cloud, and I think it's been, like lots of people have predicted it other than him, but it's here to stay. One of the real good things I see is there's a real good separation of concerns for system development. Like you don't have to worry about, like when I was at SureLogic, about like putting machines together and hooking them together. Somebody else does all of that and administers all of that, which is good. We can focus on system development. I already mentioned this, but I think reliability of like, is my pipeline flip a coin, whether it will work or not, is a problem. And too many quotas are a worry. Like when you have 60 million things you have to worry about to get your application to run and it stops there. I expect over time simplification become a theme in these. I mean, this is a competitive market. It's nice to see. We have lots of cloud providers, and I think the ones who do this stuff well that get customers will get better over time. Impact software design. So I think to really scale up, especially, you need map-reduce style things and other approaches. But the design desiderata, like what you desire out of this, is not fundamentally changed. I think all of the things we've learned over time about good design apply to this just as well, given the constraints that cloud impacts. All right. So wrapping it up. And then we can have a good discussion, I hope. Hope folks will have some thoughts. ML is a tool to solve some problems. Good one. Can do magical stuff. I mean, some of the amazing stuff that's happened at the company I work at and other places, it's just incredible. But not every problem. Model tuning and evaluation take a lot of time. Do not plan on that being quick. And beware bias in your data, because that can make you think that principled things right out of the textbooks like precision and recall mean it's better, and you can launch it and discover it's not. And the reason might be bias in your data and assumptions made about the sampling of that training data. The surrounding systems are large, much larger than the learning things. And I think they're morphing today. Like I mentioned, TensorFlow extended, Microsoft's tools. There's some codifications, but these are where like I've spent most of my time working on, and a lot of you, if you work on ML systems, would. Experiment-gated release can mitigate risk, especially if you're talking about going from one model to another. Rolling that out over time can matter. I think architectural patterns are needed here. Codifying this stuff better and figuring out what the doer checkers and extending that into less safety-critical world would be super helpful. I don't know what those are, but I challenge folks to think about that, and if you're an architect, engage in that discussion. Cloud is here to stay. It bounds designs, but good designs still are needed. And I think cloud will drive programming language change and tool change over time. I think that there will be improvements. Some of those things I was complaining about, I am quite sure there are people working on that stuff, and there will be a better world here, but that will mean that things that are very comfortable today that work great on Unix and stuff are going to be different as we move into that. And I'll come back to the software engineering and I think software architecture in general, which is the theme of this conference, has a key role to play as practice evolves. So I'll move on to questions. Thank you. Yep.
You touched a bit on the valuation of. Thanks, George. You touched a bit on the evaluation.
Yes.
Are there any gotchas you have? I know it's still in research, in much research mode.
Yeah.
Are there any gotchas you have to share with us?
In evaluating models?
Right.
Yeah, I think the key one is to boil it down to a nutshell, don't completely trust precision and recall, because the underlying data you're training on may have biases. So I think the stuff I did talk about, like experiment-gated release, that's a gotcha. I mean, I'm quite sure that a lot of the practices I kind of came into 3 years ago at Google evolved because they got gotcha'd when they trusted precision and recall and figured out, oh, we need to check generalization. So you want your ML model to do well on data that it didn't train on, which is generalization. And how you check that is a little bit ad hoc, but experiment-gated release and any technique which is trying to do something like that to mitigate the changeover so that if you discover you were fooled by precision and recall, you can back off and take a look at what's going on. So I think that's the biggest one in terms of quality. Is that helpful? Good. Go ahead.
Okay, I have a comment / shameless plug and a question.
Yeah.
All right, it was good to see that you talked about the ease of use being something that is going to be the focus. That's actually what my talk is on.
Super.
So if anybody wants to come, Thursday 1:45 for the democratization of artificial intelligence, we'll talk about how the industry has actually been moving in that direction already.
Great.
So that's the shameless plug. For the question, do you have any best practices for acquiring training data? That ends up being a huge part of this process in developing these models.
Yeah, that's a great question. And in fact, I actually run the largest human labeling team in Pittsburgh, so very much on my mind. First thing I would tell you is if you have a way not to involve humans, that's great. Number one, don't do it. So this is kind of like the concurrency. Doug Lee always says, who writes all the concurrency libraries for Java, he's basically says, if you can avoid concurrency, avoid concurrency. But now I'll talk to you. But if you can use logs, like online logs, Google does a lot of ML systems by logs, which are directionally capturing what people are doing. This is great. So there's lots of benefits there. However, when you have to get humans and run operations like I do that collect 1 million labels a day from actual people by putting screens in front of them, I think one is be skeptical. You kind of envision a system where someone shows up and is engaged and carefully considers each answer or wants to fill out 30 things on a screen. That is not reality. I've spent time in India and Europe watching what goes on. I think a couple of bits of advice I would give is have QA systems in place for this to check the people parts of this, the processes. Know that you're going to have management of this. You're going to have quality assurance costs. You're going to have all the routine management of kind of people operations that go on. That stuff's reality. To get more technical, which is probably more what your question is about, number one is keep the question simple, but not too simple. There's a little bit of human nature involved here. I see a lot of collection forms which are kind of trying to collect oh, give us an answer and you can write some information if you think it's too much. Keep it focused. Don't ask 8 things on one screen. But on the other hand, one of the simplest labeling tasks we have gets a little monotonous for the users. This is the not too simple, which is where we put up an offer and we say, is it in this category, yes or no? We call this the binary labeler. And this is a little too simple because it can lead to people hitting the no button a lot when they determine that most of the time they're going to answer 20 no's before they get a yes. So they kind of figure on average, my grades are going to be pretty good if I just guess no all the time. So we're starting to move to where we give them a choice of a few choices. So I think there's a little bit of human studies, maybe like UX, get UX people involved and think about human interaction on these labeling systems is good advice. And you know, we're starting to do that. I think historically that was not the case, and it definitely has created some bad training data. And assume things are going to go wrong. One of my favorite stories is we had like all of a sudden a group of operators just like labeled everything at the decorative bells, like for no reason. And finally, watch out for cultural differences. Like in India, cheese is not well known, I guess. So like there can be cultural, so that's going to require training if you have people working in domains that culturally they don't deal with very often. And I'm sure like in the US we have things we don't understand that are happening like in the Far East or in India as well. So it's kind of some advice. We can chat more. Other questions? Yes, please.
Oh, sorry.
So are there any people within Google whose job title is architect and who are looking at these kinds of things? So this is kind of a two-part question. So the first part is, are there any architects who could look at this?
Mm-hmm.
And the second is, are there any people like you who are making conscious contributions to building up this pattern of experience?
The first one, I think there are folks who are thinking about these things, a lot of them in our research org. A lot of the ML, I think the model that they've gone to and are working towards is where the research orgs develop these things and then we try to transfer them as best practice into the actual production environments. So I don't know if the job titles are actually architect, but the people that are thinking about TensorFlow and TensorFlow Extended are in research. Now, it isn't quite the same as if they were just dreaming this up and throwing it over the fence to us. That is not how this works. I think they actually have a pretty good model of engaging with teams. So I think I have like 4 research collaborations going on right now. So there's a lot of feedback from the production things like ads and cloud and other systems to research to make sure they're getting feedback. So I think that's like where that happens inside Google. That's a big org, but that's what they're doing. And am I helping? I don't know. I mean, I guess with engagement, with experience. We have, a lot of the systems were built up over time. The one I work on is over 10 years old. So it didn't have a lot of these kind of best practices out of research, so it was built up slowly over time. And I think just kind of getting the feedback there. And a lot of the challenges I face are probably what a lot of you are facing. You probably have aging software systems you're trying to modernize. So that's like another whole talk. I have a lot of opinions on modernization. But this is, Google has it just as well as everybody else. All the challenges of trying to transition something that's maybe imperfect but working to something that's architecturally better and more sustainable over time. Those are challenging things to do. And you know, I tend to try to push what I think are best practices in the company as much as I can, and probably have some impact in Pittsburgh. It's a big company. But yeah, hopefully that helps.
I have one question. I work actually for a company in industry which is very regulated, medical device, which means the results are produced may jeopardize patient health. So now, do you know, or maybe also the audience, about some attempts to deal with ML in regulated business? I mean, for example, this doer checker principle, the checker is easy there because it's like kind of like, well, whatever the humans recognize, that's the check.
Yep.
In sometimes dealing with applying ML to very complex problems, the checker is not doable. So what do people do, what the industry do, how the regulation goes about?
Yeah, that's a great question. Unfortunately, that is way outside of my experience. Like I said, the systems I've worked on that are ML related are like the impact of getting it wrong is revenue, which is important. You guys know that, but it's nowhere near the kind of things like you're talking about an industry that's super important, and Phil is as well. We don't want the self-driving cars like running people over at the schoolyard, and we don't want the medical devices doing bad things. I don't know, but I think it's definitely an area, I think it calls out to the need for the architectural patterns that will allow us to do things there. And it was interesting, I think like Phil's talk is probably, you know as much as I do, and you probably know far more in the medical area. But no, yeah, that's way outside the experience. And I'm reminded when I was back like in the Air Force, I was working with some contractors on some very difficult problems with like the AWACS airplane and all of that. And I used to always think like people at Microsoft knew all this great stuff. And one of the engineers, I think it's from Lockheed Martin or Boeing, I was sitting with at some conference, and I was like, wow, that looks really cool. Like, how do they do that stuff? And he kind of grumpily said, they're not solving the same problems we are. And I think that's definitely the case. So I don't know in that kind of area whether experiences at Google are going to be too helpful because of the business we do is just so different than what you're tackling, which are really hard problems with a lot of safety critical issues. Yeah.
Hey, my question is, suppose if we use the ML model in the real production system,
Yes.
and if you want to update that in the system without disturbing the system, you want to provide 100% availability, do you follow any architectural principles in your design to update that without disturbing to provide 100% availability? If it is so, what is the best practice or approaches?
Yeah. That's a good question. And it depends a bit on what you're doing. Realize the things I'm dealing with are largely coming in through like websites and things. So there's a couple techniques. I mentioned the experiment gated release, but how that's actually done is typically like direction of parts of the traffic to a new model and parts of the web traffic to an old model. So we can actually segment that and monitor what's going on. So to do that, you need like flexible ways to guide traffic coming in to your systems. You also need monitoring to the point that you can actually collect useful metrics out of like what's going on in the experimental one versus what's going on in the production one and be able to compare them. So I think there's, it can get complicated pretty fast, and that may not map to your environment. But I think in general, like switching them over live, so this is literally migrating traffic at increments of like 5% of the traffic and ramping up till you finally get to what we call a holdback, which means the new one is 95% in production with a 5% holdback, and we're just monitoring there's no ill effects. For a longer period of time, we tend to hold the holdback for much longer than we do the ramp up, just to make sure that we haven't missed anything long term. Because one slightly non-obvious thing like shopping, which I come out of, is you can imagine that experimental results we get in, say, today are quite a bit different than they are the day after Thanksgiving or ramping up to Christmas. So like we have to consider seasonal effects and sometimes through there. I think like redundancy, that also leads to a thinking that you have slots for things. So don't view it as we release it, we review it as we put it in a slot and we move traffic over to that, and that slot just happens to have the most traffic for the time being. And if you start thinking in terms of like, I'm running lots of these at one time and what's production versus what's not, tends to get a little fuzzy and is more based upon where has the traffic going, I think can lead to more long availability. I think to shut it down and put a new one out and start it up, that's like risky, very, very risky in my business. Because George and I and other people want to get paid that work at Google. They don't lose revenue. Go ahead.
You already started talking about this a little bit, but how much human intervention is there in the experiment-gated release process? And that's the first part of the question. The other part of the question is so you say what you're talking about is in that process, you're more or less comparing the new release to what is currently in production.
Yeah.
How do you avoid problems where you end up sort of drifting slowly, little bit by little bit, off of where you should be if you're just, comparing back to the most recent release, if that makes sense?
I think it does, because when we start comparing to the current model, we're assuming that differences are like moving us in the right direction, and we really don't know. I mean, the only way you can know is if you actually do like side-by-sides with humans, looking at them and going, that one's better, that one's better, that one's better. That's like the gold standard. But moving it, moving the bar there in the right direction, I think there's a lot of human interaction. The metrics are metrics. So you get, literally, you can envision, we have things that give us percentages, and we have all these little metrics we collect, and they're lined up across the top, and we can see experiment and production, and we can see the differences. It takes very smart humans to figure this stuff out and make decisions about it. It's easy for me at the top level to go, this metric generally aligns with revenue and it's going down, that's bad. Now, as you can imagine, it's a whole nother world to go, why did that happen? And that's where there are several people, like a couple on the team, that are just brilliant at this. And this is an area where, like, codifying what they're doing, they're able to dig into these systems and go into the models and what's going on in the ML itself and look at weights going in and what the features were and figure out why that's happening and usually give answers. But that's really hard. And so the answer is a lot of human interaction and a lot of checking. Typically when it's going bad is where you need that. When it's going good, there's almost none. So you need the staffing and the team to be ready to engage if all of a sudden the metrics go the wrong direction. And you've got to explain why they're going that route. All right. Others. Michael.
Hey, so about, I guess it was back in January 2018 or so, there was a nice little post on the ACM blog about the end of software engineering and the last of the methodologists. Bertrand Meyer shared a couple of anecdotes and a little bit of data about declining research dollars into software engineering, fewer and fewer students going to software engineering. Yep. And it ended with this really wonderful quote. Basically, it's time to don our hats, coats, and scarves. Winter is upon us. This talk, I think, was a bright, cheery little warm spot for software engineering. Yeah. But I was kind of curious, how chilly is it at Google?
Wow. George and I could probably do an entire day on that. This gets into another whole topic, which I think industry-wise, and Google does this, there's been a lot of focus to what I would call algorithm-focused interviewing, which has trained people to be very savvy on they can easily implement, union find and, just crazy levels of merge sort and exactly details of this. But, I find myself on CLs linking the Wikipedia page to the Gang of Four design patterns and going, you're trying to do this, I think. Could you read that and apply this pattern to your code? So I do think you see it in practice. I think design is not as hot and trendy as it was. In the heyday, we had OO and all of that, and people were gung-ho to learn modeling things and all of that. What?
He wants to ask more.
No, I just want to. I guess there's.
But I think it's a tough thing, and I think there's way more value than people think, and I hope that maybe we are in the winter, as Bertrand said, but I hope it's going to get to a thaw and the pendulum will swing back. In other words, it's kind of.
Yeah, I hope so too. That's kind of my experience, sadly, as well. And I guess there was the reason that's an interesting metaphor is there was an AI winter, I guess, for a while as well. And so we also see the research and the students are going towards machine learning and AI, which is kind of why it's, I don't know, this is a nice talk, seeing both.
Yep. No, I'm firmly with you on that. I think there's tremendous value of software engineering. I do think we have to stay open to these things and be aware of them. And like I said, I tried to place them, but all that we know is incredibly important to these kind of systems as well as it to what we call traditional systems, I believe.
So there seems to be some recurring experience coming out of organizations at your scale that apply ML systems that it is not as easy to separate modules. The coupling and cohesion gets degraded very quickly, not maybe even possible. So there's one aspect of it, maybe they're just looking at the data and the feature engineering, which is obviously highly coupled because of the way it is. But there's another aspect of it, there's a whole system around that that can be decoupled with the techniques that we already know about. So do you have any experiences that speak to either aspect of that, or have you seen that it's really not possible to separate some of these modules, which go back to your architectural pattern plea as well, maybe somewhat? So.
Yeah, so the first point I'll make is the surrounding systems, labeling systems, monitoring systems, serving systems. I think there is a move towards decoupling those. I think a lot of things you see with like TensorFlow Extended and other things, they are directly targeting that. I think they've learned over time that there is benefit to the things that like Brooks, Parnas, every architecture community has been pushing for a long time, and it's happening. Getting into the second part, which you really were asking about, like feature development in the ML model, that's a little tougher. I think the hope is that these things had to be highly tuned for linear classifiers. That was how it worked. As you move into deep learning and neural nets, the hope is that you can kind of just send lots more features into it and let it figure out what's important. Whether or not, which would clearly simplify the feature going things and decouple it a little bit. You could just say, figure out how to put your data together, shove it in there, it will work. I also think that like depending upon the company, your focus might be different. Google's obviously very focused on doing things like queries really well. A lot of the research is along that kind of thing. Other companies may take different tacks at this and solve different problems. I think it remains to be seen whether or not we can decouple the feature engineering from the type of model. That would be great, because if you could just do feature engineering and then switch out models underneath it, that'd be really great, software engineering wise. Yeah, but I think it's hard today.
One thing you said earlier, earlier about pipelines being a throw of the dice, that really resonated with me. And there were
Not the only one.
We also run on Kubernetes, and there are cases where things just stop,
Yep.
and then I have no visibility into the system whatsoever.
Yep.
And what do I tell the customer? The computer stopped, and
Nope.
it's the cloud stopped. Yeah.
Yes.
Is that so? One thing I've noticed is that what we tend to do in response to these sorts of things is we don't know why this happens. We don't have visibility in the network or platform level, so we put in workarounds to route traffic away from those nodes and wait until it stops stopping.
Yep.
Or we put in retries. And I wonder whether there is not a systemic effect of there are things at a low level broken, and we are just patching it over, and this is getting bloated and not looked at. Do you have the same feeling, and do you run into these same problems in your experience at Google?
Oh yeah, right with you. Absolutely. Now we have an army of people that figure those things out, but it's kind of not very helpful because your job still has to be killed off and restarted like 6 times, and you're sitting there 3 days later without the information you wanted, which is what I was kind of railing against. I really think I would use the model in my mind is, and usually when I think about this is, I'm kind of like, why can't this work like LS or a Unix prompt where I get an answer, even if it takes a long time? But yes, I think today we're in a situation where the tools are not good enough, the reliability is not good enough, and I think the model maybe I'm wrong, but it might be slightly broken, this idea that it's just let it kill it off and restart or all of that. I definitely think the quotas are a problem. Like probably, I don't know, has your experience been that sometimes it's like you find out it was some quota not aligned right with the customer's needs? Yeah, that one is incredibly frustrating because programmers are trying to run pipelines and get data. They are not trying to work their way through a list of 50 kinds of quotas and figure out whether their thing meets. They just want it to work somehow. So yeah, I don't have a lot of solutions. It's just more a call for like, I think this is broken and it would be nice to like work this. And I hope that there are people out there doing that on these systems. But yes, no, I absolutely believe I deal with it too.
Thank you very much, Tim.
Yeah. All right. Thank you.